Hey guys, and welcome back to a new video. In this video, we will dive into sensors in Android. So as you know, Android devices have quite some sensors you can use to gather sensor data from the outside world. And that is what you will learn today. And you won't just learn how you can actually get these values. No, I will actually show you my favorite way of implementing such sensor handling, because you can do quite some stuff wrong there if you want to integrate that in an existing architecture. I will show you an approach that makes it super easy to actually extend your app with more sensors and just to have some nice abstractions which allow you that you can easily unit test your sensors and how these interact with your other parts of the app, even local unit tests. So just the way that I prefer when I implement sensors into an existing architecture to make it scale, to integrate it well, so that you follow all the clean code practices here. And the example sensor I will use here is the light sensor, because that's quite easy to implement, but it is as easy to extend this with more sensors by just adding a few lines of code here. So even if you want to use some other sensor, you can fully watch this video. This won't be specific to this light sensor all the video long. That will really be only the last minute or so where we're implementing the light sensor specific stuff. So what will we do here? We will have this sensor data, and right now it's pretty dark here in my room, so it will say it's dark outside. But as soon as I take my phone and I hold it in light, then you can see it says it's bright outside. So the light sensor is working perfectly fine, and that is what we will do. But if you want to implement other sensors, then just feel free to watch this. Also, if you're using XML, then you can totally watch this video. The implementation and abstractions and all that stuff will be exactly the same, just a very minor difference in regards to the UI layer, but nothing in regards to sensor data. So let's first of all try to understand how I like to abstract these sensors. And if you don't know what an abstraction is, that is in the end just either an interface in Kotlin or an abstract class, and we use that to keep our code actually replaceable, so that we can also easily extend that by simply adding more sensors that inherit from that abstract class, and just that you don't have the Android specific code directly in a single class that you might use in your ViewModel or so, because then you can't really write local unit tests for that, because you can only write local unit tests if you use non-Android dependencies. So if you use something like the context, which sensors need in Android, then you can unit test that, and you need to make it an instrumented test, which is slower, all that stuff. So we will write a little abstraction, which I will call measurable sensor, because that's in the end what it is. We select class here. Let me add that to Git, and we make that an abstract class. So now we just define what a sensor should actually be able to do. We don't define any functionality yet. On the one hand, every single sensor could either be available for a device, or it could not be available, because not every device has every type of sensor. So you kind of want to have a Boolean here to check whether a sensor is actually available for a device. And I will call this does sensor exist? And that is a Boolean. Then we will have two more functions. On the one hand, an abstract function, start listening. So that will tell the sensor manager of Android later on that we would like to start to listen to specific sensors values. And if we have a start listening function, we also have a stop listening function. That makes sense, I guess. And something we want to have here is a protected val actually on sensor values changed. So whenever the sensor manager later, so the service of the Android operating system that reports these values, whenever that tells us, hey, here is a new sensor value for your desired sensor, then we want to trigger this callback lambda that I will create here. And that will give us a list of floats and doesn't return anything. And we make this null by default. Why does it give us a list of float? Well, because some sensors actually give us multiple values. For example, Yeah, for example, there's a rotation sensor that determines how your device is rotated, and then you have an X, Y, and Z value for that. If we use the light sensor, we only have one entry, then this will be simply a list of one element here. But just to be flexible, to easily extend this with more sensors, we have this as a list. Then, if we have this listener lambda here, we also want to have a function, this time a public function, to actually set the on sensor values changed listener. And here we pass that listener. Like that. And then we say on sensor values changed is equal to our listener. And that actually needs to be a var, of course. And something that actually every single sensor needs out there is a sensor type. So we need to tell Android which specific sensor we actually want to access. And that's something we can pass on the constructor. So private val, actually let's make that a protected val because we need that in subclasses. Protected val sensor type, and that is an integer. Cool. So now we have that very outer abstraction, which doesn't require any Android dependencies. That is going to be the class, the type of class we will use in our ViewModel later on to actually get the sensor values directly in the ViewModel and then take these and put it in some kind of state object. Next up, we want to add another sensor class, which will be Android specific sensors. So we will create this Android sensor class here, which will be a normal class here. Oh no, actually not a normal class. It will be an abstract class as well, because we don't want to be able to just create an Android sensor, because then we still don't know what kind of sensor it actually is. Because what we will do is we will then have another layer of subclasses that then inherit from this Android sensor class, and that will just be a class like a light sensor, like a proximity sensor, just stuff like that, which will then make it super easy to add more sensors to our app. You will see how that works. If you don't understand that now, don't worry. Here in this class, we now need some more dependencies in the constructor. On the one hand, we need a private val for the context, which we need to get an instance to that sensor manager I talked about. We want to have a private val sensor feature, which is just an integer, and that can be used to determine whether a specific sensor exists. And we actually have the sensor type we want to pass here. And that will then inherit from measurable sensor. And here we pass our sensor type, and we're then ready to actually implement this. First of all, we want to override does sensor exist. And here we will simply use our context, package manager dot has system feature, which is used to check whether a specific feature exists for that Android device. And here we want to first of all pass the feature we want to check for. That is it package manager, I think? Yeah, here, feature sensor light, you can already find that. That would check if the light sensor is available. However, we want to write that in a general way. We don't want to hard code the light sensor into this class, then this would be pretty pointless, which is why we actually want to pass the sensor feature we passed in the constructor. That still gives us an error because that needs to be a string. Just like that. And then it will work. Cool. We then, on the one hand, want to have a private latent variable sensor manager. That will be the system service from Android that will report the sensor values for us. And we will have a private var sensor, which is also coming from Android, this Android.hardware sensor, and that's null by default. And that will be returned from the sensor manager once we told them to start listening and how to and which sensor we actually want to listen for. So we will start with our start listening function. And here we first of all want to check if our sensor actually exists. So if it does not exist, we simply return out of this function. Then we want to check if this is actually the first time we call this start listening function. So if our sensor manager is uninitialized in the sensor, so we can check that using if : sensor manager is initialized, and actually negate that, and our sensor is equal to null, Then we know we called this for the first time, and we can initialize this. The sensor manager will be equal to context get system service. We say sensor manager class, and we say as sensor manager. And then we can assign the value of the sensor using this sensor manager, and we still get an error here. What is it? Nothing. I don't know. Doesn't show me. It actually shouldn't give us an error. So let's just leave it and hope it goes away. The sensor actually then is sensor manager dot get default sensor actually, and we want to pass our sensor type here. So that is how we can assign the sensor. And we actually also have an else case in which we want to simply start listening. Or actually, let's not do this in else because we always want to do this. So we will say sensor.let, and then we can say sensor manager.register listener. So we now have a sensor listener that tells us whenever the sensor value changes, it will be this. We will use this class here as a listener. The sensor will be it. And we want to say sensor, is it sensor manager? Yep, sensor manager, sensor delay normal. So this also gives us an error here because this is not of type sensor event listening yet. So let's implement that interface, sensor event listener. And now we're ready to go ahead and actually override the stop listening function, in which we of course want to stop listening to sensor values. If the sensor does not exist, again, we want to return here, or if our sensor manager is not initialized, we just return. And else we can say sensor.let again, and this time we want to say sensor manager unregister listener. Actually, we don't need that let. We can remove that, and we pass this. So we just remove the listener again once we call stop listening. And one last thing that we actually need to do in this class is, if you remember, we have this onSensorValuesChanged function, and we of course need to trigger this lambda whenever we get new sensor values. And where do we get these new sensor values? Well, we registered this listener here, so this class can now implement callback functions using this sensor event listener interface. And we can simply override these callback functions, which is called onSensorChanged, which gives us such a sensor event here. And we say if does sensor exist, if that's false, we can return, and else we want to check if that event that sensor type is actually equal to our sensor type. So we only want to trigger this for the sensor we actually requested for. Then we want to say onSensorValuesChanged.invoke, and well, now we need to pass a list of float. That will be event values, and we can actually say that to list here. And do we need this check here? Yeah, no, we don't. And that works just fine. And we still get an error here, and it still doesn't show me that. So I guess it will be fine. If not, we will get back here later. But now that we have this class that just implements the logic how any type of Android sensor works, because this part really does not change if you have a different sensor. All that is really different for sensors in Android is the sensor feature, the sensor type, and how many values you have in this list here. And since we pass a list here, we don't really care how many values there are. So that's what makes this class so useful and reusable. So we'll now go to our project package and create another class, which I will call sensors. And this will be a file in which I'll put all the different sensors we will use in our project. Since I'll just show you that with a light sensor, let's have a data class light sensor. That will take the context, and that will now inherit from, actually then it will be a normal class, and it will inherit from Android sensor. Oops. Android sensor, and we now need to pass the context, the sensor feature, is package manager feature sensor light. So now we specify the light sensor, of course, has that feature. The sensor type is, it is sensor dot type light. And if you would have a different sensor, you would then pass, for example, type rotation vector, type accelerometer for the accelerometer sensor, the proximity one. So it's really easy now to extend this. And we do get an error here because we don't implement on accuracy change. That's a function we don't need, but we can implement this in the Android sensor class. So that's a function that comes from the sensor event listener as well. We can simply say on accuracy changed, and then we say that's equal to unit. So if you care about the accuracy of that sensor, then you can also get these values here. We don't. And then now it actually tells us here's no error anymore, even though it still underlines that. Doesn't matter. So you can see how easy that now is to extend that. Let's just say you also want to add the proximity sensor, for example. Then you just take this one, paste it, and you say proximity sensor. And all you really need to swap out is this one to feature sensor proximity. And you use the type proximity sensor. So that's the sensor that measures the distance between your device and some kind of object, which is typically used, for example, to turn the screen off once you put the device to your ear, if you want to have a call or so. Yeah, but that's how easy you can now extend this Android sensor class and use a different type of sensor in your app. I will remove that again. And we will now, of course, make use of this light sensor and see how we actually can gather this sensor data. For that, I will implement a little view model. Just main view model, nothing special here. Just a very, very simple one. I actually added hilt into the dependencies. So just a quick look. Here we have Dagger hilt, the plugin, and Kotlin capped, which you need to add here if you want to follow along these dependencies, and of course the view model one. So you can simply copy these from my GitHub repository down below. And then you're good. So we want to make sure that's a hilt view model. And we say inject constructor. So what do we now inject here? We want to inject a private val light sensor. And we don't say that's a light sensor, because that would hard code this main view model to always use our specific Android sensors. However, we might rather want to actually inject the, actually not, we don't call it measurable sensor. We still call it light sensor, but it is a measurable sensor, which is our most top level abstraction here. And the advantage of that is now that, imagine you want to test this view model, you don't have to pass the actual light sensor instance, which you don't have access to in local unit tests at least. Instead, you can, for example, write a fake version of this measurable sensor class, which just simulates some sensor values for your test case. And then you can have a local unit test for this view model, even though you use some Android specific values here under the hood, which you don't really use in your unit tests then. So that's a pretty good thing to do. That's a view model. And in here, we now need to think of our logic. And this logic is actually super, super simple. Let's just go inside of the init block and we say light sensor dot start listening. That's something we need to call, of course. And then we want to say light sensor set on sensor values changed listener. Here we get these values. And since we know our light sensor will just give us a single value, we can say val lux, which is the physical unit for how bright something is. And we can get that at the very first index of our sensor values. And if you would have like a sensor that gives you 3 values, then yeah, the first one would be, for example, X, the second one Y, and the third one Z. And then we can say, okay, we actually have some kind of state here, or state by immutable state of, which is false. Actually, let's not call it state. That's not what it reflects. Let's call it is dark. So if we should show the dark theme of our app, then this is true, and else it's false. And we choose this depending on how bright it is outside. And yeah, I tried around a little bit with that. That's of course now very specific to how sensitive you want to have that. I will say it is dark if the lux value is less than 60F. And feel free to play around with that. It really doesn't matter for this tutorial. All that matters is that you get these sensor values here whenever these change, and you can very easily update the state in the view model. Let's now make sure that we can easily inject this sensor here with Dagger Hilt. So we go to our root package, create a sensor app class, and we annotate this with Hilt Android app. And that of course inherits from application. Then we go to our manifests, and here we specify the name sensor app to just register that as our main application. And we now need to specify a module in which we provide this measurable sensor. So we can say, okay, a new class that will be our, let's call it sensor module. Select object. We need to annotate this as a module for Dagger Hilt. We need to say install in. Let's just make it singletons here. We could also scope it to the view model, so really doesn't matter for this simple tutorial. And here we now specify how we create our light sensor. Well, on the one hand, we want to provide it. And that's a singleton. And I'm sorry if I go through this Dagger Hilt stuff quickly here. That's really not the point of this tutorial. I have a very detailed Dagger Hilt course on my channel. But I think it's still quick to just write this here to inject this into our view model. So we'll have a provide function, provide light sensor, that will need the application context, and it will return a measurable sensor, which we need to return here so it actually knows what to inject here. So even though we will return the light sensor in here, this one with our application, it will still need to know the type we want to inject, which is equal to this one here. Then going to our main activity, annotating it with Android entry point so we can inject our view model in here. We can quickly set up our scene. So we will have just a box for the background. The modifier is modifier fill max size. We will say, okay, the background is actually depending on our state. If it's dark, the background is dark, else it's bright. So we have val view model, first of all, is equal to view model of type main view model. And we have our is dark value is view model is dark. And the background is depending on if it is dark. If it is dark, we want to have a dark gray background, and else a white background. I'm going to say content alignment is center. To center our text, we will have in here. The text will be okay. If it is dark, the text will be white because it needs to be visible on the dark background. So color.white and else color dark gray. And what else? It is complaining. Oh, I of course want to assign the color for the text. And the text itself is also depending on that. Whether it's dark, then we will say, okay, it's dark outside. And else we will say it's bright outside. And a comma. And that should really be it here. Let's just launch this and hope everything will go right. If not, then we will simply fix this and I will see you back once Gradle finished building. So there we go. It says it's dark outside, which looks good. If I put my phone and hold it in the light, it says it's bright outside. So that looks like it's working pretty fine. Holding my hand in front of this. Works great. I hope this was an enjoyable tutorial for you and you learned how you can now properly integrate any type of sensor into your app. So as I said, if you want to extend this, you just go to your sensors file and you implement another class of sensor. And you just swap out this feature, this type, And that's it. And of course, how you interpret these values that you then get for this other sensor you would also inject here. Let me know down below how you like this video. I wish you an amazing rest of the week and amazing rest of the day, and see you back in the next video. Bye bye.